Our project topic is Ansible for monolithic and multi-tier architecture, and the group members are Darshini, Dino, Subiksha, and Yusuf. I will be doing the introduction of the project. The first one is Ansible. So Ansible is an agentless automation technology. Ansible automates application deployment, configuration management, and software provisioning. There is no need to install any prerequisite dependencies on the machine or the operating system itself. It helps migrate applications to provide better optimization and offer universal language for DevOps practices. Ansible is minimal, consistent, secure, highly reliable, and agile. This is the Ansible architecture, and I will be explaining all the components in the next slide. The Ansible architecture components include, the automation engine includes inventories, APIs, modules, plugins. Other components include networking, hosts, playbooks, CMDB, and cloud. So here in Ansible architecture, I'll be explaining all these components. So inventories, Ansible inventories are a list of hosts. So along with their IP addresses, servers, databases, they need to be managed. So Ansible takes action via transport, that is SSH for Unix, Linux. Then you have APIs. APIs in Ansible are used for transport for cloud services that can be public or private. Then you have modules. Modules are executed directly on remote hosts through playbooks. So modules can control the system resources like services, packages, or files. Then you have plugins. Plugins allows you to execute Ansible tasks as a job build step. So plugins are pieces of code, so they help in the Ansible core functionality. Then the other components include networking. So Ansible can be used to automate different networks. Ansible uses the same simple, that powerful agentless automation framework. Then you have host. Host in Ansible architecture are just node systems which are getting automated by Ansible. They can be of any kind, that is Windows, Linux, Red Hat, etc. Then you have playbooks. Playbooks are simple files which are written in YAML format, which describes the task which is to be executed by Ansible. I'll go in detail in the next slide. CMDB is configuration management database. It is a repository that acts as a data warehouse for IT installations. It holds data related to collection of IT assets. Then cloud. Cloud is the network of remote servers that is hosted on internet to store, manage, and process data instead of instead of using a local server. Then you have Ansible playbook. Ansible playbooks is the core component of Ansible configuration. Playbooks contain one or more plays which is written in YAML. Then playbooks are composed of plays and they are executed in order when administration runs the Ansible playbook command. Next, Darshini will be taking over the literature review.
Thank you, Subiksha, and now I'll be continuing with the literature review. Automating microservices deployment with Ansible. Microservice architecture, or simply microservices, is a distinctive method of developing software systems that has grown in popularity in recent years. So actually there isn't a proper definition for what is multi-service architecture. For many developers, it has become a preferred way of creating enterprise applications. So mainly the main advantage of microservice architecture is its scalability. This architectural method is considered particularly ideal when you have to enable support for a range of platforms and devices. While there is no standard formal definition of microservices, there are certain characteristics that help us identify the style. Essentially, microservice architecture is a method of developing software applications as a suite of independently deployable small modular service in which each service runs a unique process and communicates through a well-defined lightweight mechanism to serve a business goal. Okay, to begin to understand microservices architecture, it helps to consider its opposite, the monolithic architectural style. Unlike microservices, a monolith application is always built as a single autonomous unit. Basically, the advantages of microservices seem strong enough to have convinced some big enterprise players like Amazon, Netflix, and eBay. So the advantages are improves fault isolation. Larger applications can remain largely unaffected by the failure of a single module, eliminates long-term commitment to a single technology stack, makes it easier for a new developer to understand the functionality of a service. The drawbacks are developing distributed systems can be complex because microservices are basically based on distribution of all the services across the physical layers, and multiple databases and transaction management can be painful. Testing a microservices can be really complex. Deploying microservices can be complex. So basically the principle of microservices is to be independently deployable, and the complexity arises due to distributed nature. So here we have operations and the software development team that will adopt the DevOps practices to avoid silos and the deployment process. The software team will do the overall transfer of the software over the wall between the development and operations. The microservices team will have their own software artifact from conception to production. Since the whole thing is multifunctional, infrastructure as a code and automation are now necessary. The DevOps team provides the source server provisioning, configuration management, and deployment. So basically, in order to deploy the microservice with Ansible is for automation and no-cost microservices. Okay, so basically Ansible, as I said, is for automation and no-cost microservices. To show how you can run this microservices playground environment in less than 20 minutes is basically based on Ansible, where it will actually take few minutes to deploy the whole thing and run without any software. So this is actually very advantageous for all the systems to be deployed with Ansible. Automate enterprise application monitoring with Ansible. Enterprise applications are typically segregated into multiple physically and logically independent functional areas called tiers. As opposed to single-tiered monoliths, the multi-tier pattern enforces a distributed architecture that allows for enhanced maintainability and greater scalability, resulting in increased availability, resilience, and performance. Typically, all of these enterprise applications adhere to the classical three-tier architecture, which is presentation tier, business logic tier, and data tier. Their logical and physical separateness actually makes distributed applications available for scale-out, that is, horizontal scaling. This means that a tier itself gets distributed across multiple physical servers to effectively distribute the load that otherwise needs to be handled by a single node. In such a scenario, communication between adjacent tiers is handled by load balancers, which relay incoming requests to a particular node in the cluster. The complexities is basically end-to-end traceability, that is how to determine data flows in a multi-tiered environment that spans multiple servers. So basically this can be overcome by Ansible, that is a radically simple, powerful IT automation engine which is extensible with modules written in a programming language. So with these models, we can actually monitor the application, and it stands as a building block for the software where we can actually customize it according to our usage, and the enterprise application can be simultaneously monitored with the Ansible. So basically it would actually stand as an advantage for all the enterprise applications to monitor their softwares. Okay, now Yusuf will be continuing with the methodology.
My name is Yusuf Al-Ulama, and I'm going to be doing methodology and results throughout the presentation. So, our project is about converting Lab 1 and Lab 2 using Ansible. So, it's going to be consisting of Phase 1, which is implementing monolithic architecture using Ansible, and Phase 2, implementing multi-tier architecture using Ansible. Throughout the lab, we have been taking screenshots in order to prove our work, and I will be discussing those screenshots throughout the presentation. Let's begin. Phase 1, implementing monolithic architecture using Ansible. We got 3 main steps that we need to follow in order to implement and have our monolithic architecture running flawlessly. So the first step is installing Ansible in order to create a playbook that will be containing our code for both web server and database. The second one is run and optimize the playbook and check whether it's error-free or not. The third step, which is our goal, is having WordPress running and functioning perfectly. So, on the top image, you can see that I have installed EPEL package. This is important because CentOS does require EPEL package to be installed before Ansible in order to function properly. After that, I type the command yum install Ansible, and as you can see, the result is we have Ansible installed and functioning properly. Now, within Ansible, we need to configure two files, host and roles. In host, as the picture above shows, we need to insert the applications that we're going to run or we need to run. So I referenced this from our colleague Kazar's workshop. It showed how to use Ansible in a very easy and efficient way. So the second step is creating two directories within roles, Apache and MariaDB, aka our web server and database. So within our database, we need to create a task file that can contain all our code using a file called main.yml. The playbook gonna utilize this file and start installing our database. As for the web server, there's also going to be another main.yml file that's going to contain codes and yum instructions that will install our web server Apache HTTPD. Next, we can see that we need to create a secure shell key in order to allow our both Apache and MariaDB to connect and contact each other throughout the process. As you can see, we have created our SSH key and given permission to both Apache and MariaDB. And also we attached the virtual machine IP address, which you can see is 192.168.204.132 to both MariaDB and Apache in order for us to be able to connect and store data in its right in its correct location. After that, we need to check whether both Apache and MariaDB are functioning by using ping. As you can tell, when we pinged MariaDB, it have been working fine. There's no lost packets. As well for Apache. Next is actually implementing the playbook itself. So you can see here that we are checking whether our playbook is functioning properly or not, and whether there are any errors or fatal errors that stopping our playbook from functioning. The picture shows no errors, thankfully, as the previous errors have been modified and solved by our team and help from our colleague Kizar. So after having both Apache and MariaDB installed, we can see that by entering our IP address, we can access WordPress and manipulate it to our liking. As you can see here, we entered the IP address of the virtual machine 192.168.204.132, and we can see that our WordPress is actually functioning well. As you can see, Group B project part 1, which is Monolithic. Now, on to phase 2, implementing multi-tier architecture using Ansible. So For multi-tier, we're going to have two virtual machines, one as a web server and the other as a database. So we need to install on both machines Ansible and create two playbooks that are going to run on both machines and connect them so that we can have a working WordPress and a database to store changes there. So as you can see, the screenshots show that we installed both EPEL and Ansible on both machines in order for us to have the ability to create playbooks. So first we are gonna work with the web server virtual machine. First we're gonna access the hosts file located in /etc/Ansible. Well, we're gonna add our Apache server. After that, we're gonna create a playbook that's gonna utilize the main.yml file that's gonna contain our code for the Apache installation. The picture, the last picture shows what's inside our main.yml Apache, where it's gonna install Apache web server and gonna start it, and gonna create for us also a web admin and a user. Next is us checking the Ansible playbook, and thankfully there seems to be no errors this time around. Since we resolved the first errors during our monolithic, we learned what can go wrong and adjusted it to our liking, and also in order to avoid any further errors that we need to deal with. So you can see, like, by running the playbook, everything is functioning properly and have been implemented and changed. Now, for the database virtual machine, we're gonna go as well to the host and modify it so that it can allow MariaDB main YML to function within the playbook. So first adding MariaDB within the host, then creating a playbook containing MariaDB within roles. As for the main.yml within MariaDB, you can see that we created not only MariaDB server, but also we created a MySQL database called demo, containing a table called demo, where it's going to store anything coming from our web server WordPress. Here you can see the playbook containing the changes that is going to be required or going to be implemented when we run the command Ansible playbook YML. And here you can see that we created in both virtual machines an SSH key in order to enable them to contact with each other and have access to each other. The above picture shows the SSH key, and further down you're going to see how we assign them to both virtual machines and assign also an IP address to them. Next is us checking whether Apache and MariaDB are connected by pinging. And finally, we got our multi-tier architecture implemented and fully functioning. As you can see, we implemented the IP address of the web server 192.168.204.136, and you can see the title as a Group B Project Part 2 Multi-tier. So thankfully, we have achieved our goals, basically. Now, on to results. As you can see, Lab 1 monolithic architecture and Lab 2 multi-tier architecture have been both easily been implemented using Ansible automation, where you just insert the commands and it automates everything for you in a very agile way. And that's going to conclude my part. Next is going to be our colleague Dino.
Hello, my name is Dino, and I'm going to talk about the future works with Ansible. At first, the issues faced within converting both the labs into Ansible environment. So the issues were the playbooks were not able to work properly, the configurations were not done correctly, and connection between the web servers and the database servers were not established. The second, understand the services provided by Ansible in a better way and more efficient way. Here what we meant is one should really learn about Ansible and practice it more so that he can utilize it more of its services. As Ansible is an IT automation tool, it helps in configuring the systems and deploy softwares and other advancements in the IT tasks. It is really a simple and easy to use and manages the process in an agentless manner. It has a strong focus on security and reliable usage of OpenSSH. Basically, it is used as ultimately to reduce time and effort significantly. And also, we present this project in an easiest way. Third, the way we utilize the Ansible could not really be broken furthermore into simple steps. And finally, we recommend others to try it as well as it is very easy and user friendly. So we feel that Ansible is a very strong software and got a huge potential. It would be great if there was some course teaching on this, how to work with Ansible in this university. So this is a good point for it. And that will conclude our presentation. Thank you for your time.